The broadcast is now starting. All attendees are in listen-only mode.
Hello and good afternoon, everyone. My name is Anna Zylik. I am with ICF, and we are the vendor working on behalf of the sponsors of Energize Connecticut to bring these passive house and all-electric homes trainings to all of you. So thanks for joining us today. These trainings are at no cost, thanks to the sponsors of Energize Connecticut, and are part of a partnership with Connecticut Passive House. Today's training will be recorded and will be available online afterwards. A quick reminder that as part of this training and workforce development initiative, we are offering a 75% cost reimbursement for individuals pursuing either FIAS or PHI professional accreditation. So this includes the cost of the trainings and the exam, and once you become certified, we'll work with you to process the 75% cost reimbursement. So if you have any questions on that process, please don't hesitate to contact us. Next slide, Matt. So in addition to this no-cost educational training series and the professional accreditation reimbursements, the sponsors of Energize Connecticut also offer robust incentives for builders and developers who choose to go all electric with their residential buildings or pursue passive house certification in multifamily projects with 5 or more units. And on the next slide, the passive house incentive design for Energize Connecticut is shown here and includes pre-construction incentives for feasibility studies and energy modeling, and post-construction incentives for full passive house certification. Next slide. The all-electric incentive is for both single-family and multifamily buildings. It offers 2 levels of eligibility with specific design and performance requirements associated for each, and has incentives amounts ranging from $1,500 per unit for multifamily up to $10,000 for single-family homes. So our goal is for everyone involved in the construction of residential buildings in the state of Connecticut to be aware of these incentives. So if you are interested in learning more, please visit our website or contact us directly at the address on our slides. And as for questions during today's session, please feel free to use the chat function throughout, and I will relay them over to Matt, our presenter today. So with that, I will turn it over to today's presenter, Matt Evans.
Thank you, and welcome everyone to this afternoon's training. I'm Matt Evans with Newport Ventures. Just going to go through some background information on myself, then I'll jump into the training. I'm a building systems analyst, certified HERS rater. I've been doing this line of work for up to 17 years now. I'm beyond my 16 years with the new year. Member of ICC, ResNet, Northeast HERS, and a number of other organizations as well. I've been providing different types of trainings across the country for all these years now, 17 years. Building science courses, plan review courses, energy code courses, going back several energy code cycles. A lot of in-person courses. Some of them run from 4 hours to 8 hours in length. A lot of Zoom calls, a lot of webinars I've been doing as well for a number of years. When I'm not doing trainings, I help to support research projects at the state level here where I am in New York with NYSERDA. I also help to work on research projects nationwide with the federal government, with a number of organizations. We recently just finished up a research project on how to better air seal apartment houses and townhomes cost effectively. We worked with a builder out in Colorado to collect data, research, and compile information and come back with a really good plan. So if anyone's interested in hearing more about air sealing townhomes, cost effectively air sealing townhomes and apartment buildings that are being newly constructed, definitely reach out to me. I can send you some documentation on a report we're going to have published soon. We also recently just finished up a 2-year project on cold climate heat pumps. We used a home here in New York State in climate zone 5 and had an existing home retrofitted with a cold climate heat pump and heated that home and collected all types of data on it. And we're currently working with Oak Ridge National Labs on putting together a final report on that project. The technology with heat pumps has jumped dramatically, especially in the last 5 years. And we'll talk about that briefly as I go through today's training. My background is construction. I started doing construction projects back in high school. Went off to college, stayed with a contractor that I worked with through my college years. Got an associate's degree from SUNY Delhi, bachelor's degree in vocational education from Oswego University. Taught for 10 years at the secondary level, doing vocational education courses with high school students and also technology courses with high school students when I left the vocational education center. I also, somewhere along the line, was able to get a master's degree in curriculum development. So good background in construction trades. Still do it when I have free time, not as much as I used to in the past. So real quick, today we're going to talk about all electric homes. Personally, for me, I've been involved on a number of projects over the years with builders here in New York and some builders nationwide that do work on and build all electric homes. We have homes that are net zero. We have homes that are zero energy ready. We have homes that just meet basic energy code requirements, but they're all electric. So we'll talk about all of that and go through the training today. We'll identify current innovative high performance technology options. We'll identify the envelope efficiency considerations, which is a must if you want to do all electric homes. We definitely want to have a very robust building envelope to start out with. We'll look at evaluating the feasibility of the different options that are available. There's lots of them to choose from nowadays. We'll look at how to measure homes' energy consumption, the modeling software that's out there that a rater like myself uses. And then we'll do a conclusion, and I can answer questions at the end as we come to the 1:30 time slot here. So real quick, let's take a look at where we currently are in the United States. And this is an older slide. I do plan on putting in a new one here. But currently in the US, 26% of the households are all electric. And as you can see in the Northeast where we're all located, the numbers aren't that high. But the thing is, we do have all electric homes in the Northeast. It's doable. It's being done. As I said, I've worked with a number of builders that are doing all electric homes that are net zero. I even have a project down the road from our office building here in Schenectady, New York. It's a net zero apartment complex. The entire complex is all electric. All of their energy is produced on site. They do solar hot water, they do solar electric. And that apartment complex was so successful, they went down the road and built a slew of other units that are all net zero. So it's something that's being done. And these apartments go back 8-9 years ago when they first started that project. So the technologies are getting better and the numbers will increase here as more states, communities look to going to all electric homes. So what is currently in your home that's all electric? What can we switch over if you're in an existing home? You want to think about what you could possibly switch over. In my case, for me, I simply went with, I have a high performance gas furnace, 96% AFUE, and my air conditioning unit died, whole house air conditioner. So I looked at the options. Do I replace the AC unit with another one? Or I went ahead and I purchased a cold climate heat pump and I put in a heat pump for my house. Now I have the advantage of doing all electric if I want for heating with the heat pump, or doing what we call a dual fuel system, having the gas and the electric combined for an existing home. For new homes, you're really going to look at doing a better building envelope and looking at going all electric, because your state and other states and communities are looking to go that route, and that's what's going to be required. So systems that are in your house that are probably gas, your furnace, your boiler, your water heaters, all of those can be swapped out. All of those can have replacement options available that are all electric, that have good incentives attached to them if you buy them, good rebates, and they're energy efficient too. And they work very well in colder climates. So the technology is there now. One of the first things I want to get out of the way, obviously, if you're talking about going all electric, is solar. Is solar an option where your house is located? Can you put solar on your roof? Can you put solar on your property? If you can't get it on your roof, you don't have enough square footage. Or is there no option for solar at your project, at your home? Like in my case, I don't have a good house for solar because of the amount of trees that I have around my home. But with newly constructed buildings, you see developments going up, and what was empty farmland or open areas where there's not a lot of shading, not a lot of tree cover, all of a sudden solar becomes a really good option. You can orient the building the right way to take advantage of the sun. Currently in the United States, we have 3.2 million homes that have gone to solar. And you can see on this chart here, and these are numbers from last year, that the installed prices have been going down dollar per watt for all the solar that is getting installed. So it's getting cheaper, and the size of the systems are slowly increasing, because originally we were putting solar on home to try and offset some of the electric costs. Now folks are looking at, hey, I can actually put enough solar on my house and offset all of my electric costs. And that's what I've done with several builders. They have homes, they get all of their energy from the sun, and at nighttime, because they have excess energy from the solar panels during the daytime, that is fed back into their home basically for free. And the nighttime, when they're using their lights and their heating systems and their washer and dryer and all that stuff. So the technology's there. Solar is an option. It's not an option for everybody, but you also have other options. If you can't get solar on the house, you can do a solar farm. You can tap into solar that way. Distribution systems have to be looked at and considered. When you produce energy at your home, that's a very efficient method of having electricity. When you have to distribute it, you have energy losses through the power lines coming to your house. So producing on site versus bringing it in is probably the most efficient way of doing electricity at your home. And now, and we're going to talk about this, battery storage systems have become a cost-effective option. Still expensive, but it's slowly decreasing. So we'll get into solar battery storage for homes in a little bit during this presentation today. So why do we want to go all electric? One thing is basically the greenhouse gases, climate change, all these buzzwords people don't want to hear about or they want to ignore, but there's definitely something going on. So going to an all-electric option is not a bad thing. One of the neat things I always like to point out to folks is, oh, coal, we can't get away from it. Look at the percentage drop from 2008. Back in 2008, 51% of our electricity was produced by coal. That is now down to 19.5%. We have come up, we have other methods of getting electricity production done in the United States. Gas is still high, natural gas, just below 40% now. It used to be higher. Nuclear has dropped over the years, but a couple new nuclear plants did go online. Renewables is the growing segment, and you're going to see a lot going on with renewables. And remember, renewables consists of a lot of different things. So that's something that's going to be growing over the next 5, 10, 15 years. And this, I'll have to update this number. Solar and wind account for 13.6. Solar and wind. Oh, no, that's okay. I just looked at that quickly and thought I was wrong, but it is correct. So solar and wind account for 13.6 of our overall renewables, which is pretty impressive. Combustion safety. Homes are built tightly nowadays. So having an all-electric home is a good option to look at. Non-sealed combustion appliances, they would need to have mechanical rooms built with makeup air. So if you have a gas furnace, natural drafting, you're going to have to put that into a room that has to be drywalled and insulated, and mechanical room, a mechanical ventilation or ventilation brought into that room from the outside for combustion purposes. That costs money. Why not just spend money on more efficient systems for heating your home, for your hot water? That additional mechanical room is an added cost. You can use that money elsewhere. Non-sealed combustion appliances are typically less efficient. So we'll talk about the different items that you can put into your home that are all electric. Rooftop PV and small wind turbines have substantial potential to provide electricity with little impact on land, air, pollution, or CO2 emissions. And fossil fuels, as we all know, are being phased out across the country in different areas. California, Washington, Massachusetts are just a few examples making big pushes. Here in New York State, we're looking at an all-electric energy code by 2025, 2026 for all newly constructed residential buildings. So it's happening. So this is stuff, the good thing is this is all stuff that can be done now. It has been getting done. More than half of the energy use in a home, by the way, is heating and air conditioning. We're going to talk about that. Water heating is the next big ticket item in a consumer's energy bill. An all-electric home within properly sized heating and cooling and not non-tightly built home can create several issues. Luckily, with newer codes and requirements to seal our homes up tighter and then ventilate them properly, ideally with an HRV, heat recovery ventilator, or an ERV, energy recovery ventilator, you get a really good gold standard for a home. When you build it tight, well insulated, get good mechanical ventilation in the home. This is a photo you've probably seen over the years. Homeowners complaining about being cold in their home, and then they're turning on their stove and putting a fan there to blow the heat around. Not a cost-effective option. We have better approaches than that. And believe me, over my years as an energy auditor, I've been in a lot of homes where homeowners were heating their houses or trying to heat up rooms with the kitchen stove, either gas or electric. So real quick, the energy use, as I said on the last slide, about half of it, more than half of it, is going to be heating and cooling. So we have our heating here, 42%, and our cooling, 9%. You combine that, we're over half. Then our next big item here is water heating. You have this all other column, which is your TVs, your phone chargers, your alarm clocks, etc. But these are items here, heating and water heating, that we can address with all electric homes. Lighting, we're going to talk about that briefly. Hopefully nowadays, everyone has made the leap over to LED lighting. Lots of changes in LED technology. The lighting quality of the lights have gotten much better. I know there's still a small group of people that are affected by LED lighting, but give it a chance. Take a look at what the options are out there with the lighting, but we'll talk about it briefly. So let's take a look at different areas of a home. Existing and new electrical technologies are rapidly becoming more cost effective and more reliable than fossil fuel systems in a variety of planning scenarios and climate zones. Currently, a mix of gas and electric systems dominate the built environment for new construction, but the electrification of all the residential energy and uses is desirable for many consumers. Regulatory developments stress decarbonization and therefore favor full electrification as a low emissions building approach. Today, we're going to take a look at fully electrified buildings as one where we look at space heating, water heating, cooking through the use of air source heat pumps, ground source heat pump water heaters, induction cooktops, etc. We'll even briefly talk about the building envelope insulation, energy management systems are all considered part of the fully electrified home, or FEH, if you will. So let's start out with something simple. We'll take a look at lighting. LED lights, for the most part, are 75% or more energy efficient than what your old incandescent bulbs were, and much more energy efficient than they were just 10 years ago. The technology is getting better with each new version of LED lighting that comes out. I'm sure a lot of you this year or last year, when you're out at the store, have purchased LEDs. It's actually difficult to find the incandescent bulbs nowadays. And I won't even talk about CFLs, compact fluorescent bulbs. Those I call the gateway drug. CFLs were more energy efficient than incandescents, but they don't even compare to what LEDs can do. They had their shortcomings, CFLs did. So the good thing about LEDs, there's a lot of options with them, color options, brightness, longer lives, etc. Just be mindful about the manufacturers and what brands you buy and all of that. And also, one thing I want to point out, if you have tried LED bulbs in your existing home and you didn't like them, you weren't happy with them, consider this. Was it a dimmable LED bulb that you installed and you were trying to dim that LED bulb with an existing dimmer in your home? You do have to swap out dimmers and get a dimmer that is compatible with an LED bulb. Older dimmers in homes just can't handle the LED technology. They don't work properly. It can also potentially be a fire hazard. Something to keep in mind there. I invite everybody, go online. You can basically type in LED calculator. This is one we pulled up here, but you can easily go online, walk around your home, see all the light fixtures that you have in the house, any bulbs that you have, count them up, see what the wattage of those bulbs are, and then see what the LED manufacturers have. Here's a scenario we put in here. Wattage of existing bulbs, 40 watts, 6 watts for the new LEDs. How long are they on per day, days per week? Put in your energy costs, and you can see a really cool scenario here with the calculator on your energy savings. If you put in the true energy use and how often you use lighting in your home. For some of you, you might not have a lot of lights on in your house. It's not a big deal. That's fine. But for other folks, you got 4, 5, 6 people in the house, lights are on, lights are left on, etc. This can add up quickly, and this is just to kind of show you the energy savings that can come into play when you do replace lighting as it burns out, or when you build new construction. New construction nowadays with energy codes, basically you're looking at 75 to 90% of all newly constructed homes, depending on the energy code that's adopted in each state, have to do high efficacy lighting. I work with builders here in New York. 100% of their homes are LEDs no matter what. It's just become the go-to for lighting. So that's my little rundown with LED lighting. I'm going to move on. Next up, we have to heat our homes. And over the years, heating is an important thing, but over the years, cooling has become a big thing too. You'll see a lot of homes built nowadays where heating and cooling systems are installed at the same time. It used to be older homes would have heating, and then we would do a window AC unit and another window AC unit. Now it's standard practice to see whole house air conditioning installed with newly constructed homes. And I've seen this happen in New York, up in the Adirondacks, an area that you would never even see air conditioning. You now see air conditioning installed in these cabins in these houses because the summers are a little bit warmer. They're getting longer runs of higher temperatures. So air conditioning has become a more standard practice, even in colder climates. This system here, this is a home I did several years ago. This house had a ducted system, forced air system for heating and cooling. This is the indoor unit, and this is the outdoor unit. This is an air source heat pump. It's designed to run 365 days a year. It's up on a stand. Where this is located in New York, they average about 70 to 80 inches of snow a year. So, you know, we got to get it up off the ground. So this system is operating in this home. It's been running just fine. The homeowners had no complaints. Their home is maintained. They set their thermostat at 70 degrees. The system maintains 70 degrees year round. This operation number here, economically down to 5 degrees Fahrenheit, that's a number that's changing. This is a number we put into this presentation a few years ago. That number is changing. That's getting even lower and lower with economical operation with these newer cold climate heat pumps. They are able to provide efficient heating and cooling. They can deliver 1.5 to 3 times more heat energy to a home than the electrical energy it actually consumes. It offers a legitimate space heating alternative in colder regions. And the systems that you can put in, here is a ducted system throughout the entire home. This is in the basement. It's a 2-story house. You can also do the mini split systems, the wall mounted units, if you don't want to have ducted systems. You can do multi-zone or single zone. Off of the outdoor unit, you can run it to ductwork. With the piping, you can also tap in a mini split and have a wall mounted unit. Maybe you do that in a room above a garage where you don't want to run ductwork to it. So you just run the mini split over there. So you have a lot of flexibility with heating and cooling in the homes. One of the key things I want to point out here, when you do heat your home with a heat pump, air source heat pump, you're going to basically set your thermostat to 68, 70 degrees, whatever you prefer, and you're going to leave it there. These systems operate best when they're left on and left alone. Set the temperature and leave it. And the neat thing about newer homes, they're better insulated, they're tighter built. They're going to maintain that indoor temperature a lot longer than an older home that was leaky. When it gets windy out, you feel that breeze moving across the room. You don't have that issue in newer homes. So you set your thermostat and you leave it at that setting. Same thing we do with hydronic in-floor heating. Basically, you leave the system on and let it stay at its own temperature throughout the wintertime. No need to go up and down on that thermostat. Ground source heat pumps, basically an electric heat pump that exchanges heat with the ground or groundwater. Ground source heat pumps take advantage of the fact that the temperature of the earth below the surface remains fairly constant. In the US, the average ground temperature is about 55 degrees throughout the year. It's going to be cooler in the northern zones, warmer in the southern zones. But the fact is, once you get down 5 feet below the Earth's surface, you have a steady state temperature, which now you only have to heat up to get to a comfortable temperature in your home. You only have to bring it up from, say, the 55 degrees up to the 68 or 70. Obviously, the output of your ducted heat is going to be well over 100 degrees, but you don't have to do an outdoor temperature that might be minus or might be 10 degrees or 20 degrees because you're using the ground temperature that you're bringing up to a comfortable temperature in your home. So like an air source heat pump, the ground source heat pump will provide year-round comfort in the home. The heating and cooling ability of these systems can be ducted or hydronic. System installation include wells, loops, horizontal, vertical drilling can be done, pond loops. If you have water nearby, will transfer temperature from point A to point B. And you can also claim some rebates and tax incentives if you go and look at ground source heat pumps. This particular system here was financed at $140 a month. to pay for the ground source heat pump system. And in a newly built home with a 15, 30-year mortgage, putting another 140 on top of that, it's cost effective for the homeowners. They can pay that in their mortgage and then get a nice all electric home, energy efficient home as well. So the technology comparison real quick, the air source heat pump technology is going to be less expensive, but it's also going to be less efficient. It's an efficient system, but it's going to be less efficient than ground source heat pump. Incentives available for both. Lifespans are a little bit shorter with air source versus ground source. The actual system installed outside the home for the wells, those can last well over 50 years. Once that whole system is installed, you'll be replacing the parts inside the home once or twice before the outdoor system breaks down or even becomes a consideration for breaking down. But the systems themselves, typical lifespans, 20, 25 years. Some will say 15 years. These are the same numbers we hear with gas furnaces, etc. Space requirements, not much space for the air source heat pump because the unit's going to be outside. With the ground source heat pump, you're going to need a little bit more room in your basement area if you have a basement. But you're going to need a little bit more room for the system to be set up and piped properly. I do invite everyone to check out this website. I call it Desire, DSIRE USA. You can just go to Google, type in DSIRE, and it'll come up. This is an excellent website. The entire United States pops up on the screen. You can select your state, and then your state will pop up, and it'll show you all the state and nationwide incentives available that you can access either for residential or commercial properties for new construction or existing construction. So definitely check out that website for incentives and rebates. Heat pump water heaters. I just got back from a trip down in New Orleans where they're installing heat pump water heaters that plug into standard household outlets. So we have technology now for heat pump water heaters where you can just plug it into a standard household outlet and get hot water from the heat pump technology. Heat pump water heaters typically 2 to 3 times more energy efficient than a conventional electric resistant water heater. Air source heat pump systems can combine the heating, cooling, and water heating. I have a client that is heating one of his homes with a heat pump water heater. They ran radiant tubing into the floor. He gets hot water from the heat pump water heater, and he heats his house with the heat pump water heater. So a lot of neat things that you can do with these systems. There is an upfront cost that's higher over that of a conventional storage water heater, but the lower operating costs will quickly realize a cost savings within a year or two. Easily if your other option was a standard electric water heater. So as I said, they have 120 volt systems that plug into a standard household outlet, or you can go with the larger systems, 240 volt. 7.5 million water heaters are replaced annually, and the biggest problem we have here is homeowners replace their water heaters almost immediately. And they don't think about what the options are. What they do is they discover they don't have hot water one day. They go into their garage, into their basement, wherever the water heater is, in the closet, and say, oh, I have no hot water. They call up a plumber. Plumber will come, see what they have. They'll basically swap out system A for system B. It's basically the same system. We'll go back in. And we really want to reach out to people and say, listen, look at your options that are available. That's 7.5 million water heaters a year that are replaced. Imagine if we just get a quarter of them, especially if they're standard electric water heaters, get them replaced with a heat pump water heater, the amount of savings these homeowners could realize. But as I said, 85% of the water heaters are emergency replacements. And there's a lot going on with heat pump water heaters, with how you install them, the cold air output. We actually have a separate course. We actually have a hour and a half, 2 hour training just on heat pump water heater technology, the good, the bad, and the ugly with that technology. But the technology's there, they're being used. Geothermal and water heating is another thing to look at. If you have a geothermal system in your house, you can tap into that excess heat from the system to have hot water for your home. We do this with what we call a de-superheater. It will take waste heat from the compressor of the geothermal system, give you the hot water that you need for your home. Basically, you're getting hot water for free while that system's operating. That is true both during the wintertime and during the summertime. And if you have a shortcoming of having hot water, you can have a standard electric water heater installed or an air source heat pump water heater installed to make up any differences. And an example that we like to give here is you may have colder water entering the home, and the geothermal system of the de-superheater connected to it can heat up that water to 85, 90 degrees for free. And then you got to bring up your water temperature 125. Use the air source heat pump water heater to get it up to the remaining temperature that you need. You're not going from 40 to 125. You're going from 90 to 125. That is energy saved. Your utility bill is going to be much lower. Solar water heaters. This is a project that I worked on 14 years ago. This was a solar water heating system that was installed on a home. You see the two panels over here. The home also had electric installed. This particular house, we did CFLs everywhere. CFLs were the thing back then. LEDs weren't really out or cost effective at the time. But this is a system that's fully operational to this day. This is the setup in the basement. This is the setup on the roof. This solar water heating system includes a storage tank, solar collectors. There are two types of solar water heating systems. There's active, which have circulating pumps and controls, and then passive, which don't have the pumping system. You can also consider tempering tanks that help to passively preheat incoming cold water. So basically, a passive preheat system is having a tank in your basement. If you have the space, you have an uninsulated tank in your basement. The water comes in from the street, sits in that tank, and slowly warms up to whatever your basement temperature is. Then you only have to heat up the temperature to get it up to the 125 that you want for hot water. So that's a good passive way of getting things up to temperature. You also want to consider water distribution in your homes. You want to move away from the old method of how we ran water lines. This is a good system. I did this in a house I remodeled several years ago. We did a home run system, and the house had to have all of its piping replaced anyways. But this is a system I installed in a house built in 1890. Because we had water flow issues, this system worked very well. This is actual photo of a net zero home that I was the rater on about 2 years ago. This is the distribution system for the home. This is in the laundry room, and you have your hot water lines going out from point A to point B, and your cold water lines going out. So you have this particular home had 2 bathrooms and the kitchen, obviously. So you have your hot water to the sinks, you have your hot water to the showers, to the tubs, to the sink in the kitchen, hot water to the washing machine, etc. But point A to point B, PEX tubing was used. Costs of copper has gotten up really high. So these are quickly run. And what's neat about this net zero home, they did a double studded wall. So they had a 2x4 wall exterior, and they did 24 inches on center framing. And then on the interior, they did another 2x4 wall. In between the two 2x4 walls was a 3.5-inch space. This builder went with an R15 rock wool insulation in the exterior wall cavity. They did an R15 continuous between the walls, and then came back and did rock wool R15 in between the studs on the interior wall. This home has an R45 wall And if I remember correctly, the attic was about an R64. This home was built slab on grade. They opted out of doing solar for the home, but their utility bills in this all-electric home are typically right around $100 a month. And it's a 2-bedroom, 2-bathroom house. Utility bill is right around 100. If they ever do invest in solar, they won't need that much to power the home. Everything in the house is all electric. Their water heating is an air source heat pump. They're heating and cooling the home with an air source heat pump. And guess what? They're up on a mountainside heading into Vermont from New York State. The homeowners never had issues up there. Even when there was a power outage last winter, 3 days later when the power came on, the indoor temperature was still above freezing. She told me they were about 55 degrees inside, even though the power had been off for 3 days. So a well-built home, really good insulation, higher R values, tightly built. You're going to be okay during the power outages. And that's been a fear with a lot of people with an all-electric home is a power outage. Newly constructed home, you're going to be fine for a number of days. Heat pump dryers. This is another thing that you can see and purchase currently. Heat pump dryers have significant advantages over cheaper dryers. You may spend a little more initially on a heat pump, but there are many benefits that outweigh the early costs, the higher costs you put in. These heat pump dryers are super efficient. They do a reheating and recycling process. Heat pump dryers are about as energy efficient as it gets, with most of the models scoring the maximum Energy Star rating that's available in the market today. You're saving yourself a lot on money, operational costs, and more than half of the energy use of the vented electric dryer is saved. More than half of the energy used in a standard electric dryer is saved when you use a heat pump dryer. And you do not have to vent these to the outside. You'll see that the water is what condenses down, and that's your exhaust. It's all safe to keep in your home. Heat pumps, basically, from the reporting we've gone through, heat pumps use about 50% less energy than a standard electric dryer. So that right there, if you do a lot of laundry, if you use a heat pump dryer, you're cutting your drying costs by half. And other benefits that we noted, heat pump dryers are gentler on the clothes that are in there. As their drying air temperature is considerably lower than the conventional dryers, heat pumps are less abrasive on your garments. They feature multiple sensors to detect moisture, so your clothes are dried more consistently and treated with better care. This saves you from replacing them due to wear and tear or shrinkage. So a lot of advancements to look at with heat pump dryers. Home battery systems, I mentioned this early on. These are things, they're still expensive. The price is coming down. But what's neat about home battery systems is if you have solar, you can charge these batteries up, and if the power goes out, boom, you still have power. When a standard house with solar loses electricity, the power goes out, you have no electricity, even with solar on your home. The only way you'll have electricity is with a battery system. So the neat thing about them, you can buy different size systems. They have available 3 to 14 kilowatt hours. Costs are ranging from $2,000 to $12,000. But what's neat about it is you could buy a small system and add to it as time goes on. You can add to that system. And one of the neat things we've been reading about is what they're doing with vehicles, electric vehicles. For example, Tesla, a lot of their batteries for their vehicles, after 10 years, they don't really want you to use them anymore. But there's still lifespan left in those batteries, even at 80% efficiency. You can take those Tesla batteries and put them into your home for a battery system and get another 10 or 15 years out of them to have battery backup systems in your home, or just to power your house. If you don't even want to be tied to the grid, the technology is there to have total battery system installed and have solar on your house and be disconnected from the grid if you wanted to do that. All the technology is there. Speaking of batteries, I was just saying this, you have EVs now, they're promoting them. We've seen the TV commercials, the power goes out, you go out in your driveway, you can plug your EV into your house and power your home with your electric vehicle. You know, this is not something you want to, oh, let's power my house every night with my electric vehicle. You don't want to do that, but the options there, if there is a power outage, there is a storm, you do have the ability to power your home with your vehicle. So that's really cool technology. Your home can charge the car either through electricity from the grid or from the solar or from the batteries, but then your car can turn around and power your home as needed. So there's a lot of cool things going on with EVs for your homes. Induction cooking. You can get this for stoves and for cooktops. They use a magnetic current to directly heat your pots and pans. Notice this person's hand is on the stovetop. You will not get burned. It is impossible to burn yourself with the induction cooktops. You do have to buy specific pots and pans to make it work, but there's no lost energy to the air like you have with an electric stove or with gas. Only the cookware is what's going to be heating up. It has precise temperature control, and you need induction, as I said, you need induction compatible cookware. And what's a really neat thing here is these induction cooktops can boil water faster than a gas cooktop. You can typically bring 6 quarts of water to a near boil within 2 to 4 minutes. That's pretty darn quick. So take a look at induction cooking stovetops and for ovens, the stoves and cooktops. The technology's there, it's available now. Definitely take a look at that. What about the fireplaces? They have some really cool fireplace technology nowadays. This one happens to be a shot of one that's using water vapor with LED lighting. It has a water reservoir in it to produce the fire effects. It looks real, but it's cool to the touch. If you want to have the system actually heat your room, not recommended because now you're spending energy on heating. But they have additional heat systems that can be added to it and can typically heat up to like a 400 square foot area if you did want to feel the heat. But that's a pretty realistic looking fireplace right there using water vapor and LED lighting. Think about putting these into a finished basement area, maybe in a living room, dining room, wherever, but the technology with fireplaces has definitely evolved with LED lighting. It's there. Check them out if you're interested in having a fireplace and not doing the wood burning or the gas fireplace. Another big thing with energy efficiency in all electric homes is really knowing the energy consumption in your house. I've worked on smart homes for several years now. Smart home devices and technologies are available in stores online. You probably have some app on your phone that lets you operate or control your heating or cooling system in your home. Heck, I have on my phone the ability to access my refrigerator and to change the temperatures on my fridge and to turn the ice maker on and off if I want. And I was just looking recently at the newer washer and dryers. You can access them via your smartphone if you want to, but the home monitoring and control, all this market, Bluetooth technology, Wi-Fi, is all to our advantage to really see what we're spending energy on and see where we can make cost savings and scheduling things. So, I mean, you can track your energy consumption with smart thermostats, track when you want to have the system on or off or change temperature settings, dimming your lights, reducing temperature settings, remotely turn stuff on and off, etc. The home monitoring and control market has really taken off the last 5 years. And one of the neat things that I really like is some newer electric panels that are on the marketplace now. They call them the smart electric panel. When these systems get installed, if you're going to build a new home, consider looking at a smart electric panel. You can actually see every single circuit in your home as it's connected and how much energy is being consumed at different parts of the home. And what's neat about these smart electric panels, if the power goes out and you're going to power your home with battery backup, you can actually use your phone to turn off systems in your house and just have this smart electric panel focus on keeping power to your refrigerator, power to your freezer, power to your lighting systems in your home. You can actually do that with your cell phone with the power out because of the connection between Bluetooth to the smart panel and to your phone. So you have the ability to turn things on and off remotely. And the neat thing is the smart electric panel will actually show you how much energy you're consuming, and it'll show you the energy consumed at each circuit, etc. It's a really cool system to check out. So innovative, high-performance technology options. Majority of them are off the shelf nowadays. You can get them at your retail stores. You can get them at the warehouses, etc. Your HVAC companies have them. They're aware of them. I have one HVAC contractor I work with. They're moving out of the gas furnace install realm, and they're going to be switching over to all air source heat pumps, and they're looking at possibly getting into geothermal. So take a look at the newer equipment. Take a look at what's out there now, rebates, incentives, the energy savings with the newer systems that are all electric, and then compare them to standard electric equipment too. You know, just because you have to pay more up front, you know, am I paying $1,000 more for option A versus option B? But what's the payback? How much energy do I save when it's in operation? Heat pump water heater that I mentioned earlier, a lot of those things will pay for themselves in 3 or 4 years, but they'll last 15 years plus. So think about your options, what you pay up front and what your utility bills will be at the end of each month. So now let's take a look at the envelope efficiency considerations. Air sealing insulation levels, windows, doors, house layout, and placement of items in the home. Here's another example of a double-studded wall house, slab on grade. You can see where they have the rigid foam at the slab edge. It's right below the concrete here. But a high R value wall, that's just one option. You have other options. You know, I think I have some of them in here with SIP panels, OSB with foam in between, ICFs, the insulated concrete form, basically an R22, R24 styrofoam block with concrete in the middle. You have different ways of showing compliance with energy codes. You have path to an energy efficient home. Prescriptive path will give you a couple options. It'll tell you basically code minimum requirements for doing things for your building envelope. Performance path in the energy code allows you to look at above and beyond code items and to take advantage of tax incentives and rebate programs that are either state or nationwide. But performance path allows a rater like myself to model the home before it's ever even built, to see what the energy costs might be in that house and to see what your different options are. Do I do a heat pump that's air source? Do I do geothermal? Do I do solar? Do I do what size water heating system? What type of window do I put in? Double pane, triple pane? What are the U factors? All these things can be looked at and considered well before the home is built. So here's just some snapshots of some projects I've worked on. Here's a slab on grade house, lots of foam going underneath. This happens to be an R38 of insulation under the concrete. Basically, the house was built as a cooler. Foam on the ground. The walls and the roof are all air permeable insulation using rock wool and blown in cellulose to insulate the home. This house with that air permeable insulation was below 1 air change per hour for the blower door test. Super tight home, attention to details with air sealing, like the gasket here before the wall is stood up, sealed to the concrete with an adhesive and then the rubber gasket. So think ahead of time how you're going to do things. Plan ahead. Don't make these mistakes. This is a house I was in years ago. the window size for some reason changed by the architect or the homeowner. And look at what the framer did. Instead of redoing this opening, they just framed out the window, kept adding lumber. And the R value for a typical 2x6 stud is a 6.88. And if our wall, this particular home had R21 put in the wall cavity, there's R21 missing all around here because that is all studs. 1, 2, 3, 4, 5, 6. 6 studs. 1, 2, 3, 4. 4 studs. A lot of excess framing. This is, I couldn't believe I saw this on a job site. Wasted opportunity to get insulation in that wall. Air sealing will help improve the comfort of the home, lower utility bills, improve indoor air quality, increase durability of the home, and it impacts the manual J. That's the sizing of your heating and cooling systems. The better insulated the home and the tighter we get the home, the smaller our HVAC systems can be. The smaller those systems are means the lower cost the client has up front of buying those systems. They're not paying for something they don't need. So air sealing is a key thing. You have options around window and door openings to do foam, but you can also do a backer rod like this and then caulk it. You don't have to do the foam. You want to air seal these locations. Around electrical boxes, caulk the opening to the wall. What's a tube of caulk cost? Take the time to caulk this. A lot of energy codes require this stuff be done, but I tell builders all the time, even go around the interior walls of a home and caulk the boxes to the drywall. All these air sealing efforts are going to go a long ways to a more comfortable home and reduction on your energy costs. Here we have a home that we did aero barrier in. Aero barrier is that aerosolized spray that goes into the air, and it pushes into any cracks and crevices throughout the home and reduces the air leakage. You can do this before drywall goes up or after drywall goes up. We've done it on existing homes. We've done it on new homes. But some of you have probably heard of the product Aero Barrier. That's a really neat way of getting a home into compliance with the blower door tests that are required in many locations around the country. Insulation levels have changed over the years. This is referencing the 2021 IECC levels, your different climate zones, your ceiling R values, your wood frame walls. This is assuming wood frame walls. I work with builders, they don't even do wood frame walls anymore. They're doing the ICFs, they're doing the SIP panels. But these are insulation levels that have increased. You even have a requirement now, not a requirement, but an option of doing an R30 in a wall cavity. Well, how do you fit an R30 into a 2x6 wall? Basically, you're going to have to go with an open cell or a closed cell foam to get to the R30, but the code is still flexible enough that it allows you to do an R20 in the cavity with an R5 continuous. But this is prescriptive approach. If we go performance path, we get some other options available. Maybe we can just go with the R23 in the wall cavity and meet code that way. Very doable. So this is just guidance in the energy codes. Windows. This is from the 2021 International Energy Code. And we have our different climate zones, 1 through 7 and 8. Fenestration U factors, 0.30. You're probably seeing windows that are 0.24, maybe 0.27s, 0.28s. A lot of builders and architects aren't even selecting code minimum windows anymore. They're doing better than code. A triple pane window will get you down to the 0.18, the 0.16 U factor. With U factors, the lower the number, the better. With R values, the higher the number, the better. So you really want to dial in what you need, what code wants, or do you want to do better than code? And this is another all-electric home project that I was involved in. This home was all spray foamed. What's neat about this window, these were imported from overseas. These windows, 100% rubber gasket around the perimeter. You can shut this window. It swings open like a door. You can shut it, turn the hinge the other way, and it'll swing open at the bottom. It opens 2 different ways. Really cool window, triple pane window. A little bit of added cost to it, but a lot of flexibility with that design. Think about how you lay out your home and where units are placed. Where do you want to install the HVAC system? Where does the water heater want to go? So think about that layout. Do you tuck your furnace or your heat pump distribution system off to the corner of the basement, or do you centralize it? What about your water heater? Do you put that in another location in the basement? Maybe on the left side here, but your kitchens and bathrooms are all on the right side. Think about distance, think about distribution, think about how much plumbing you have to run, either copper or PEX tubing. Think about ductwork. Do I want to do central returns, or do I want to do returns to each room? There's costs associated with those decisions. So you want to think about locations of systems in the home and how you distribute everything. All these can have added efficiencies to your benefit. And if you plan it out right, you can reduce the costs on installing the system. So these are things to consider and think about. So we have homes and apartments, townhouses, all of those that can be all electric. It's already being done. You build these structures tight, and I would recommend you go with the gold. We call it the gold standard heat recovery ventilator, or ERV, energy recovery ventilator, for ventilating the home. Get to above code insulation levels. Don't just build to minimum levels that are in the energy code. And look at above code programs like Net Zero Ready Homes or Net Zero and Beyond. This is a snapshot of that apartment building down the road from our offices that's all electric. Each one of these cold climate heat pump units mounted on the backside of the building goes to each apartment, and there's 2 mini splits mounted in each apartment to heat and cool those units year round. So we've got about 28 minutes left here. I want to get through the remaining slides. So let's take a look at feasibility of different options. Current practice and going above and beyond current practice with what builders and architects recommend or they do. What are the cost impacts? Where are we headed in the future? New home construction allows for builders to throw out past practice and to move to best practice. Out with the old methods and in with newer methods, newer systems. Change is a good thing, especially in the construction industry. So current practice, just building the code minimum requirements, just putting in bare bone insulation levels that the code book calls out. Well, that's fine if you want to be just bare bones, just meeting code. Let's look beyond that. And also do a better job of installing insulation. If you're going to use air permeable insulation like fiberglass, great product, but you got to install it properly. For example, air permeable insulation like fiberglass has to be covered on all 6 sides with an air barrier to maintain the R value. So an air barrier is your top plate, your bottom plate, your left and right stud. That's 1, 2, 3, 4. Then your drywall on both sides, 5 and 6, or sheathing, whatever you put up on the other side. This happens to be going into a garage. That's item 1 to maintain our value. The other one is don't compress the insulation. Once you compress air permeable insulation like this, the R value decreases. So look at how well insulation is being installed in homes. Measure airflow. Here we have our black box. We use this to measure airflow in all of our Energy Star homes that we rate. We put this right over the bath fan, and this will tell us how much airflow is running through that bath fan when we turn it on. And I'll give you a hint. If this bath fan was labeled as 80 CFM, you'd be lucky if it's pulling out 50 CFM. What happens a lot of the time with the bath fans that are installed in homes, the contractor will run a flex line. They'll run a 4-inch flex line, and they'll have turns and elbows in it, and it takes a long distance to get out of the home. That's very restrictive on airflow. I would definitely bare minimum do a high efficacy bath fan like an Energy Star bath fan that has a 6-inch opening on it to run a larger duct out of the home. Hard pipe it if you can. But measuring the airflow is an eye opener for homeowners and for contractors. So that's why I'm always suggesting do the heat recovery ventilator or the energy recovery ventilator for whole house mechanical ventilation. Advanced practice. Here we have a ICF home, just the foundation. Other builders I've worked with, they do ICFs from the foundation right up to the attic. Here on the right is a SIP house. That's an OSB with foam in between. Both of them create super tight homes below 1 air change per hour for the blower door test. Easy, quick, effective way to air seal a home is using one of these two options. You can effectively air seal a home that's stick built as well. 2x4, 2x6 home. I've had them rate well below 1 air change per hour when there's an attention on air sealing. But basically, look at what other options are available. If you do a SIP house, you basically can have that structure up within a day or two and have the roof on it. You can even have the roof that's a SIP roof panel. You can have that whole house shelled in within 2 days. The ICF house, you're basically building a concrete home with continuous insulation on both sides. It's going to be nice and tight, air sealed, and you've already taken care of all of your insulation needs. You don't have to come back and pay a contractor to insulate the home. It's been insulated already. So look at the costs of the systems, but look at the labor savings and time savings. And all of these newer product, well, newer, they've been out for a number of years now, but you can get smaller HVAC systems installed now. I work with a builder now for 14 years. And when I first did an Energy Star home with them, they were installing gas furnaces that were 120,000 BTUs, the size. That same size home nowadays, they're installing gas furnaces that are 66,000 BTUs because the home is built tighter and there's more insulation in the house. We've almost cut in half the heating and cooling system that the home even needs. That's a cost savings for everybody involved. Here's an example of a manual J report. Over here, there's information on the window, but you'll notice here the HVAC company that did this manual J calculation did not look at the plans. They put in that all the windows were 0.57 U factor. That doesn't even come close to meeting code. This particular home had windows in it. I don't think we have, there it is. Windows are 0.23. They had 0.57 down. They put in that the wall R value was R19. This home actually had wall R value. Do I have it on here? I might not have it on here, but this home, I believe, had an R23 for the wall. They show the foundation walls R25, but look at their numbers that they used. Window area was wrong. This is what the HVAC company gave us versus what we actually had from the job site. Above grade wall area was off. So the manual J reports got to get much better. You definitely want to take a look at them, get them more accurate. So let's move in real quick to evaluating the feasibility of different options in the energy code and above code homes that are going to go all electric. There's modeling software that's available out there, software like REM-Rate and Ecotrope you've probably heard of. This can give us results for the HERS index or the energy rating index. It can produce documentation for above code programs. All of this stuff is happening now. We can also use that modeling software to determine what amount of solar panels will need to be put on the home to take away, offset all the electricity used in the home. So we can actually take data from a solar company that puts a quote together for a homeowner, put that information into the modeling software to see if that is going to truly offset all of the electric, or if we have to add or remove panels than what they recommended. So energy consumption, over the years in our homes, the U.S. average, you can see, has dropped by household. Homes are built tighter now, better insulated, more efficient equipment. So it's been dropping. And this information stops at 2015. We do plan on updating it. But the homes are much more much more energy savings than what we've had in the past. You can see that in the diagram here with what's been collected. So here is, if you want to take a screenshot of this, but it'll be available online too. These are the three most common softwares: RunRate, Ecotrope, and Energy Gauge, that a HERS rater like myself will use to model a home before it's even built. And then we go into the home, we collect all the data on it, and then we put in our final numbers into the software to produce final documentation for the home. So we can actually tell the homeowner, tell the client, it's going to cost you this much to live in the home based on the way it was built, based on actual results. So we can work with the architects directly to say, hey, do I want to do an air source heat pump? What's the cost of it? What's the efficiencies on that system versus a ground source heat pump? What's the cost? What's the efficiencies? You can plug all that different information in. The modeling results will tell you what to look for. So here's some of the outputs you'll see with the modeling software. It does an hour-by-hour calculation looking at 30 years of weather data for a home's location, and it will do a calculation on what the energy consumption will be. This particular home that we had built, its total annual energy cost was $623. We had solar put on the home that offset its energy costs by close to $1,800. And the homeowners were fine with paying for the solar and then paying $623 over the course of a year. Could they come back and add more solar and offset this? Absolutely. Have they done that? I don't know. I haven't been to this house in a number of years, but we were able to produce a home that scored a 9 on the HERS index scale. They didn't go for the Zero Energy Ready Home program. They were going for the tax credit, but you can see the different requirements here. They met the New York Energy Code. This is where the home was built, and then there's annual energy costs and our infiltration, ventilation rates. All of that stuff is considered in the modeling software. So home rating system, the HERS index scale, basically a 100 is a house that was built to the 2006 Energy Code. The IECC would score 100. As new versions of code come out, the number gets lower and lower. So most new homes are going to score well below 100 nowadays. They have to, especially if you're in states that have adopted the IECC as part of your energy code. You're under the 2015, the 2018, the 2021. Are you looking at doing the 2024 energy code? Well over 3 million homes have been rated via the HERS index, and that number continues to grow year after year. The HERS rating index was established back in 1995, and it's a great way to see where energy efficiency has come, how far along it's come. But what's neat about the HERS index, as a rater like myself, we go in, we test the homes. We're kind of a third party verifying that everything is working properly and working efficiently. And they anticipate well over $8 billion in energy cost savings for homeowners. That's based on data from 2021. That number has definitely climbed. So getting there with software. I was talking about the software that we use. Here's another all-electric home. This home has solar. It has geothermal. This house is one that I modeled numerous times before the homeowners made a decision on what systems were going to go into the home. So I started modeling it, and we had them down to a 40 on the HERS index scale. Remember, the lower the better. We had their annual energy costs right around $2,000, but this is a couple years ago, so electric rates were much lower. And mind you, they did choose to go with solar panels on the property. So we did even more modeling. I ran more simulations with their home, and our ultimate goal and what we estimated was to get them down to a HERS index of 0. The modeling still showed that they'd have to pay a little bit on energy costs, still $33. Reality is, once we went in and tested the home as it was completed and finished, and we checked back with the homeowners, looked at their utility costs, their actual HERS index ended up being a -6 at the end of the day. They actually get money back from the utility company because their home is so energy efficient. They did an Energy Star home. Their ceiling was an R58. We went with walls that were R30. We had an R10 continuous. We had windows that were just 0.27, double pane windows. They looked at doing triple pane, but the cost of the triple pane windows was a lot of money. They'd rather use that money elsewhere. And they went with a standard double pane 0.27 U factor. And their home is really robust. Solar array. They had it. They didn't have it mounted on the home, but they had it mounted out in their yard, so it could track with the sun. So a really cool home, all electric. Homeowners are the ones that worked with us. They were their own general contractor, and they were able to do it on their own. House was up and built within a year's time. Building envelope priorities: insulation quantity, insulation quality. Make homes tightly built, air seal everything, and get in whole house mechanical ventilation. Look at your window performance and look at your house orientation to improve on efficiencies by orienting the home the right way. Above code programs, DOE, Zero Energy Ready Homes. We help facilitate this program out of our sister office down in Maryland with Newport Partners. It's a high performance home. Efficiency threshold for this particular project, you have to get down into the 50s or lower. Each house is project specific. Nice thing with Zero Energy Ready Homes, we evaluate indoor air quality, we evaluate comfort, moisture management, and is the home PV ready if we ever want to add solar to it. Other above code options is Energy Star, LEED for Homes, National Association of Home Builders Green Building Program, and Passive House. So you have these other above code options. We want to get builders away from just building to code minimum. Look at these above code programs. Zero net energy project locations. California is leading the nation. When it comes to those programs, Massachusetts is number 2. Vermont and New York is mentioned as well. So zero net energy ready homes, are starting to see more and more of them being built. With the future, all electric homes are going to become smarter. You're going to have remote and real-time energy usage, smaller size versus larger size. We want to move away from these large homes that people really don't need. New homes of today and tomorrow can look exactly like the homes of the past on the surface, but there's so much happening below the surface of these walls, below that roof line, that we don't see. Smart technologies in your refrigerators, your washer and dryer, Wi-Fi, Bluetooth systems, controlling temperatures remotely, notifications if a door's left open in the house, shutting that. Things determining if you have independent zone controls in each room. One of the houses I showed you earlier, each room had its own thermostat in it, so they could isolate a room if no one was going to be using it. So that is energy savings. There's a cost associated with doing things like that, but it can also be cost savings. And we're already doing this with Habitat homes. We have Habitat homes going up across the country that are all electric. Habitat homes are being built above code. They're using a volunteer force to construct these homes. This particular home here in Massachusetts scored a -7. It's a basic home. They went with the Superior Wall Foundation, which is a precast concrete foundation with rigid foam built into it, and then you can add insulation in between the cavities. The foundation can be set on stone, compact stone. Goes up quickly, it's bolted together, and then you build the house on top of it. Straightforward design, everything's all electric in the home. That's a Habitat house, and that's a video link talking about this home if you wanted to follow that. Here's another all electric home. This is one I was a HERS rater on. This is a slab on grade house. They took their time, paid attention to details. You'll notice the water lines are up in the ceiling, but you'll notice the ceiling is separated from the attic by OSB sheathing. On that OSB sheathing and above it is the insulation for the attic. So they kept all the piping, all the plumbing inside the building envelope to keep it from freezing. They even wrapped it with insulation. This foam insulation you put over the pipes is relatively cheap and easy to put on. So this is an all-electric home done in New York State. This is basically the details of the home. Double-studded wall. They did OSB sheathing on the roof. Attic is vented. Furring strips for spacers. And the attic has an R70 blown-in cellulose. Foundation is an R38 triple pane windows, 0.13 U factor, with air permeable insulation throughout the entire home except the rigid foam at the slab. This house was 0.69 air changes for the blower door test, with air permeable insulation in the wall, air permeable insulation in the attic. Super tight home, mini split system heating and cooling the home year round, heat pump, water heater, 100% LED lighting, all Energy Star appliances, water conservation system, whole house is EPA WaterSense certified, energy management system. The homeowner has an app on their phone. They can look at all the different components of the house real time. Low and no VOC paints, HRV system installed, etc. Really nice house. 2-bedroom, 2-bath house, 1 floor, just under 1,200 square feet, climate zone 5. We modeled the home over and over again to determine what to use. They even use some newer products for their electrical boxes. Here you have a nice surface area to put a bead of caulk on and then set your drywall into it. And then you can come in here and fill these gaps here and here with spray, with foam or caulk. You don't want to put anything inside the electrical box, but here and here you can fill it with caulk or foam to air seal so there's no leakage with the wiring there. And then existing homes. What can you do to make existing homes more energy efficient or converting them over to all electric? And this happens to be a snapshot of a home where it looks like the roof would be a good option for all this solar. But this particular home, 3 different solar companies came out and they all said you have to get rid of the trees. You can't see them in this picture, but they said basically you'd have to get rid of these trees here to make this system work year round to get anything efficient out of it. So look at your home design, look at the location, look at if you have enough sun to get solar on the roof if you want to do that. There are solar calculators online. You can check out energysage.com. That's a generic solar calculator. Basically what's neat about it, you put your address in and see if solar is a good option for your home. And then finally, a couple more slides here and then I'll be done. Energy efficiency for new and current homes. You have new mortgage options, green choice mortgages. You have different ways of financing energy efficient homes. Covers up to 50% of the home's appraised value. Improvements of over 6,500 will require an energy report that a HERS rater like myself can do. HERS rating is a great option to produce an energy efficiency mortgage report to get lower mortgage rates if you want to do that. A couple things I want to make everyone aware of is we're now using new terminology. You've heard SEER and HSPF with heating and cooling systems with heat pump technology. We're no longer using SEER, we're using SEER 2. It's a new metric, new and more efficiency standards for heat pumps and AC units. The test methods changed and the rating metric have changed, so we're now using the term SEER 2. No longer were we going to use the older numbers. Those were outdated basically last year. We're now using SEER 2, HSPF 2, EER 2. Those are the new standards, new requirements for heat pump technology. Closing thoughts. Hundreds of cities and corporations are on a path to zero carbon emissions. For most to achieve this ambition, and best path to generate all energy renewable electricity, then electrify all buildings and transportation. At present, only 1 out of every 4, a quarter of U.S. homes are all electric. Most of them still use natural gas for heating, water, heating and air, and cooking. Some use gas for washing and drying clothes and dishes. Natural gas is typically 85% methane, a super pollutant that traps 100 times the heat of CO2 over its 16-year life in the atmosphere. Much new natural gas used in buildings comes from fracking, increasingly associated with polluting local watersheds. Unless all homes and buildings are heated with renewable electricity instead of natural gas, we will fail to fully decarbonize. The good news is there's an increase in all electric building at the same time as there is a price decrease for renewables, heat pumps, and energy efficiency technology and materials. So any questions I can take now? I do want to put up this next slide here for some resources to check out. Building America Solution Center, great website to check out. Zero Energy Ready Homes is another website. You can just go to Google, type in these keywords and get them. These are our 2 websites, Newport Partners, Newport Ventures. And if you have any questions at all, this is my email address right here. And that's the slideshow. I'm going to pause now, get a drink of water, and I can stay on for a few minutes here if there's any questions. But if I don't answer your question today, feel free to email me your question. I'll answer your email. So thanks, everyone. I'll pause now if there's any questions.
Thanks, Matt. Yes, there are some questions from people in the audience. We have a few minutes. First one is, how do you size an ERV?
The neat thing was sizing ERVs, energy recovery ventilator, or an HRV, heat recovery ventilator, is with modeling software like REM rate and energy gauge that I showed you earlier. As a rater like myself, we put in all the information about the home into the software. It'll actually suggest and tell us what size the unit should be. And then once we get a size based on the software, we can go out into the marketplace to see what's available. Generically, the mechanical code in Connecticut, the mechanical code in any state, generically the mechanical codes will tell us what size ventilation systems should be, but it's a very generic guide. I strongly recommend if you're going to do an HRV or an ERV, you get a HERS rater or someone with access to modeling software, and it'll be pretty darn accurate when it comes to what size system should be installed. Hopefully that answered your question.
Thanks. Next one is, what are the best and perhaps popular for builders ERVs, and how many watts do they run at?
The person that asked that question, if you email me, I don't promote any product one over the other. Over the years, I've seen a lot of really good HRV, ERV systems that operate. One in particular that I can think of, HRVs, ERVs are meant to be left on 24 hours a day, year round. And there's one particular brand out there, they promote it as the same electric consumption as leaving on a 100-watt light bulb year round. And they promote it as maybe it's going to cost you about $80 a year if you leave that thing on, which they're designed to run continuously. So you can get as low as $80 is what I've seen manufacturers advertise. Others can cost you $200 to $300 a year to operate, but your energy savings from using those systems, because you're getting a benefit from those systems because it's preheating, pre-cooling air coming into the home, where an exhaust-only system, you're venting out your conditioned air and it's just leaving your house. ERV and HRV at least is preheating or pre-cooling the incoming air. So yeah, they use energy, but the cost savings associated with how you build the home and operating them recover that quickly.
Okay. Thanks. And another question might be the last one, about what is it cost for a HERS rater to do a HERS rating and energy model on
That
this one's a little
that's
specific, on a single family 2,000 square foot home?
Yeah, that's gonna vary depending on the rater. And I will recommend go online. Northeast HERS is a good website. NEHERS. You can go onto the Northeast HERS website and you can put in your state, you can put in your county, and you will find raters that are available in your area and find out from them what they might charge. Generically for us, I work directly with an architect. I'll start out with a basic price of like $1,000, but that $1,000 covers me doing a couple simulations with their home, doing the modeling, to tell them, make recommendations, what systems, what R values they should use, HVAC systems, etc. Anything. Basically starts out at 1,000. We do a couple, and then if they want more simulations done, we add on to that cost. But that cost can also include the blower door test, the duct leakage tests, measuring bath fan airflow. So the costs are going to vary depending on locations and who the rater is, etc. But $1,000 is a typical starting point, I would say.
Okay.
And it's well worth the investment to get any hiccups out of the way early on. For example, I got an architect to change their window package. They were going to go with a window package that cost them $10,000 more. And I modeled the home. And I said, listen, that $10,000 more window package is only going to save you about $70 a year in energy costs. So for them, it was a no-brainer to switch to a different window. And they were okay with $70 extra in energy costs because they're saving $10,000. So it's worth the investment, I think.
Yeah. All right. Thank you for answering that. We are at 1:32, and I think we have answered all the questions that have come in. So I think we can wrap it up here. Thanks, Matt, again for a great
Thank you.
presentation. And yeah, thanks again to the sponsors of Energize Connecticut for bringing these passive house and all electric homes trainings. And we will call it an end here. Have a good.
Sounds good. Thanks, everybody.
Yep. Thank you. Have a good rest of the day.
Bye.
Bye.